Today's lesson is lesson 82, and it starts on page 496. And I think you'll find it's a lot easier than yesterday's lesson. At first, when you see that the title involves logarithms, you're probably going to think, oh no, logarithms. And you know, if that you were here in class with me and you said that, the first thing I'd do is ask you to go get a drink of water and come back with a better attitude, because logarithms aren't that bad. So when you look at this problem, you might think, gosh, how in the world are we going to solve this? That's a base 10, that's a base 8. They're not the same, they don't cancel out. Well, you're right, they don't. But if, in this case, because there is a 10, if I take the log of both sides of this equation, remember, if you look at your calculator, above the word log, L-O-G, or below it sometimes, you'll see that there's a 10 to the x. That tells you that this is understood to be a base 10. Understood to be a base 10. We don't have to write it if it's a base 10. But what happens when we take the log of both sides, in this case, because this is a log base 10 and that's a base 10, this cancels out. Now nothing cancels out over here, but at least over here, now we have minus 2x plus 2 equals log of 8, and I don't have to write the base 10. Well, the object of this is to solve for x. So we need to subtract 2 from both sides, and remember, these are not like terms. I can't subtract the 2 from the 8 because this is log of 8. This is not a log. This is just minus 2. And then we need to divide both sides by negative 2. Now, if you want to just leave the answer in that form, it's fine with me, except that you can't leave this negative in the denominator. Instead, we have to take it up and make it minus log of 8 plus 2 over 2. Remember, if you take this negative up and multiply it times everything in the numerator, everything changes sign. Now, if you want to put that in the calculator and give a decimal answer for it, you can, but you don't have to. It's fine to leave that as an exact answer. If I put it in the calculator, parentheses, I'll just put 2 minus log of 8. Close my parentheses twice, divided by 2, gives me 0.5486. 0.5486. That's the answer. Or, like I said, it's fine if you want to leave it in exact form. When you get into college, some of your pre-cal and Cal 1, Cal 2 classes want you to leave it in an exact form anyway, so that's fine. All right, so let's try another one. This one doesn't have a 10 in it. It has an E. So when you see an E in a problem, what does that make you think of? See an E, what does it make you think of? Natural log, right? For the same reason that log LOG is base 10, natural log LN is understood to be a base E. So you can probably guess that if we take the natural log of both sides here, remember, ln is an understood base E. So you can see that these will cancel, and we'll have minus 2x plus 3 equals ln of 5. And we want to get the x by itself, so that would be equal to ln of 5 minus 3. And it's not 5 minus 3, it's ln of 5 minus 3. Divide everything by a negative 2. And again, if you want to leave it in that form, it's fine, except for this negative right here. I'd have to take it up and multiply it here. So that would be minus ln of 5 plus 3 divided by 2. And if you want to do it on the calculator, you can. It would be 3 minus ln 5 divided by 2, which gives me 0.6953. So either one of these is correct. All right, the next example looks like, what in the world are we going to do? There's no e to cancel out. There's no base 10 to cancel out. How can we solve this? Well, you can do it one of two ways. You can either take the natural log of both sides, or you can take the log base 10 of both sides. Does it matter? Excuse me. No, it doesn't matter which one you do. You can try it both ways and prove it to yourself that it really doesn't matter. So I'll just take the log of both sides. And you have to remember what we know about the rules of logarithms, the laws of logarithms. It's the same thing that applies to any exponent. Because remember, a logarithm is just a fancy word for exponent. So this right here and this right here are powers. So by the laws of logarithms, that's an exponent, so it just gets multiplied by the other exponent, which is log of 5. Same thing over here. The x minus 2 comes down and it's multiplied by the log of 6. Remember, if we had something like this, what would we do with the exponents? We would multiply, correct? So this is a power. It is being multiplied by the other exponent. That's a power. It's being multiplied by the exponent, which is the log. All right, so now when we do this, we distribute. So we'll have 2x times the log of 5 minus the log of 5. And over here, we'll get x times the log of 6 minus 2 times the log of 6. Now, even though we don't know what the log of 5, log of 6 is, those aren't variables. We can put those in a calculator, or we can leave it as an exact answer. So those are not what we're solving for. The x's are what we're solving for. So we need to get all the x's on one side. So 2x log of 5, bring this over, minus x log of 6. And at the same time, I can take this across and make it log of 5 minus 2 log of 6. Okay, now keep in mind what it is that we're trying to solve for. We're trying to solve for x, correct? So we need to factor the x out of here. If we factor out an x, which means we divide by x, then we get 2 log of 5. Minus the x cancels, we get log of 6. And this stays the same. Log 5 minus 2 log 6. And then to get x by itself, what do? We just divide both sides by 2 log 5 minus log 6. 2 log 5 minus log 6. So that would cancel. We'd have x equals. And I would strongly suggest that you just leave this alone. Don't even try to put it in the calculator, because there's so many parentheses that have to go on here. Remember, that would be this quantity divided by this quantity. But when you put log in your calculator, it's automatically going to bring up a parenthesis. You have to close that. Same thing here, and then close the bracket. Same thing down here. So there's a lot of places that you have to put a parenthesis in. But if you want to, you can go ahead and get the decimal value for that. You just have to be super careful. So I'm putting parentheses, log 5, close the parentheses, minus 2 log 6, close it twice, divided by, open a parentheses, 2 log 5, close it, minus log 6, close it twice, and then enter. And when I do that, I get negative 1.3833. Because the calculator is doing all the work on these problems, I need you to round it off to 4 decimal places. But like I said, it's much safer to leave the answer like that. If you insist, there's the decimal answer, but I'll have to take off points if you have it correct here and you don't get it correct out of the calculator. So just be real careful. And like I said, it's not necessary to do this. All right, one more problem on this lesson. We have 4 equals 6e to the 2x plus 3. Well, if that 6 wasn't there, we could take the natural log of both sides and get rid of the e. Well, 6 is just multiplied times that, so let's just divide it. Okay, so that would be 2/3 is equal to e to the 2x plus 3. And then what do? Now we take the natural log of both sides. So ln of 2/3 equals ln of e to the 2x plus 3. That cancels. So then we would have 2x plus 3 equals ln of 2/3. Subtract 3 from both sides, so 2x will be equal to ln of 2/3 minus 3, and then just divide that by 2. So x would be equal to ln of 2/3 minus 3 divided by 2, and if you do that to get a decimal, see, ln 2 divided by 3 minus 3 divided by 2 is negative 1.7027. Again, like I said, it's fine to leave it like this. If you want to get the decimal, there it is, but make sure you do it correctly. All right, so this lesson is due to be uploaded on Wednesday, and again, make sure that you upload all the pages and write at the very top of your lesson how many problems you did.